Okay, great. I think we can get started. Let me share my screen. So the installation. Let me answer this question. So installation steps are same in Windows and as well as in Mac. There are no difference. The only difference is you have to use terminal for to running all the commands in Mac, and in Windows you have to use Windows PowerShell, not your command line, right? That's the only difference. We'll see at the end of the session if someone is facing issue still, we can just work together. Okay, but steps are same. I don't think you should face any issues. Same steps, no difference. Okay, so let me share my screen. Okay. Uh, Nachiket, is my screen
Yes, that is
visible?
visible. Disable the notifications. Voice is also clear.
My voice is clear, right?
Yeah, it's clear.
Okay, great.
Guys, we'll be taking the installation doubts at the very end, and do not practice side by side, please.
Okay, so let me start the recordings.
Ankit, disable the annotations. So
Yeah,
at the
I'm
right
just
end.
doing it. Yeah.
Yeah.
Okay, I think I disabled. Yeah. And let me start the recording.
Recording in progress.
Okay, great. Welcome back, everyone. The day two of Namaste Spark Bootcamp. So just a quick summary, what we learned yesterday, right? We first learned what is big data, right? And a lot of emphasis was on understanding the difference between monolithic system and distributed system, right? So we understood why we even need distributed systems, right? Because managing distributed systems is difficult, not easy, because it is a cluster of systems and managing is not easy. So there should be a strong reason why we need it, right? And we understood it, what is vertical scaling, horizontal scaling. And when it comes to distributed computing, we also understood that first technology which was open source technology, and we can run the cluster on the this normal machines, right, was Hadoop. So we understood how Hadoop works, how MapReduce works, how we split the work, and then combine it, all of that, right? Today we will start with Spark, right? And before that, I just want to spend some time on Docker, right? So we did the installation on Docker, and yesterday we didn't have much time to talk about it. What is Docker and what exactly we are doing, right? We just followed some steps and it is running, but we should have at least some basic understanding what is Docker, right? So Docker is a tool that lets you package. So this is not a Docker session as such. Even I don't know much about Docker. Just an overview so that we all understand what we are working on. So Docker is a tool that lets you package your application and all its dependency into a container so it runs the same everywhere, right? So let me draw a board to explain it in a very easy terms, right? So let me create a new one. Let's call it Docker. Okay. So now let's say you are building an application, right? Any application, it can be a web application, backend application, it can be Spark application. So in our case, it is a Spark application, but container is for everyone. It is not specific to Spark or anything, right? It works for software developers, for data engineers, everyone, right? Let's say I'm developing a Spark application. I have written some code and all, right? And it is working fine in my machine, right? Now, when I have to run this Spark application, it is not just application, it is not just code. There are a lot of other things that I have to have. For example, I need to install Spark, right? So Spark, let's say ours is 3.5.1 version, right? Apart from Spark, right? Before even we start with Spark, we have to have Python installed. We need to have for PySpark, right? For PySpark, we need Python. We also need to have Java installed, right? And there are few other things that we need, right? So all these things with particular version I have installed, right? So let's say 3.8 I have installed and Java some version 10. I'm just randomly taking. and Spark this. And on these installations, right, my Spark application is working fine, absolutely fine. Right, I will have maybe some more configuration setup and all, right? So I have all of this in my system, and I have built a Spark application, and it is working perfectly fine in my system, right? So this is my system. Now let's say you give this Spark application to someone else, right? Let's say there is a new person joining in your team or new whatever employee, right? You give this Spark application. Now you will not give installations. You will just give the application code. You will not give the full installations of Python, Java. You will say you install it. Right? Now it might be possible he has a different operating system. Maybe this was Windows and this is Mac. Or maybe he has a different setup already. He has Python 3.10. Already it was there. So he thought, okay, I will use Python 3.10. Right? Or Spark 4, let's say, or some other configurations are there, right? Then what will happen? It might be possible that same application which was running here, it might not work here, right? Because there were some libraries of 3.8 which were decommissioned or whatever, right? It is not compatible. The application code is not compatible with whatever installations the other person has, right? So one is different versions other person can have, or they can have a different operating system. They can have a Linux, Mac, and I have done on Windows, right? Anything. Right? And this was a big problem, right? Because having everyone in everyone's system having the same installation, same everything was a difficult thing, right? So that's where Docker helps me in rectifying this problem. So what it will do, it will create a container. So you have your machine, right? So you have this machine, right? Let's say this is my machine, right? And this is my host, full machine, right? Now in this machine, I have my operating system, right? Whatever operating system and some memory, right? And CPU, everything. Now you imagine container as a we are taking some part of this machine and creating a container in this. So imagine, right? Just for imagination. So let's say from your whole machine, I'm taking some part of your machine. Let's say this, right? Right. And in this, uh, I think I should change. Okay. Right. So this, I will create a container here using Docker container. Yeah. Right. And in this, I will install everything, right? So in this container, I will install whatever is required. So what will happen? This guy, right? He will give me a container image. Container image will have everything that what all has to be installed and the application code both the things he will give. Now, when he will give, using that image, right, I can create a container, right? Using Docker, I can create a container. So image is like a blueprint, right? That this is all is needed. And then on this machine, I will share the image, and with Docker, you can create a container, and that container will install everything. So whatever is there in your system, it doesn't matter, right? It will create a kind of virtual environment, different virtual environment in your machine, right? Now it is independent of whatever you have installed Python, whatever version Java, Spark, whatever. In this container, all of the setup will be done for you, right? With the same set of configuration, installation, everything, right? So now this application will work as it is. You will not get that error that this version is not supported, this and that, right? So this makes life easy, right? So this is a very common thing you would have heard in software engineering, right? That this is working in my machine, but not working in some other machine or not working in prod, right? This is a common thing because version mismatch is always there, right? Someone is upgrading version, someone is downgrading, but application was built on particular version, right? So this is what these containers or Docker is solving the problem, right? I hope you got the idea, right? Let me read the definition, then it will be more clear, right? Docker is a tool that lets you package your application and all its dependency into containers so it runs the same everywhere, right? And the beauty of it is independent of the operating system as well, right? So you have different Docker for Windows, for Mac, if you see installation. So same image will work for Mac as well as Linux as well as Windows. So you don't have to create different image. Okay, for Windows, this should be it. Docker will take care of it, right? Docker will take care of it, right? Let's imagine you want to run a Spark application. What do you need to get Spark working on your machine, right? Of course, you need to write Spark code, but code alone is not enough. Right? To run Spark, you need Java, Spark binaries, Python, correct version of libraries, environment variables, proper configuration, right? Setting up all this manually is different on Windows, Mac, Linux, and often leads to it works on my machine problem. Right? Docker solves this by allowing us to bundle Spark, Java, Python, and all required dependency into a single package called a container. Right? We run this container. Right? Spark runs in a clean, isolated, and consistent environment the same way for everyone. This is why we are using Docker for Spark setup. So I have, to be honest, first when I was working, right, I'll show you my notes. Okay. So this is my notes. Okay. So you see Spark setup on Docker. I have put it in GitHub anyway, but I did it on my system as well without Docker on my system, Windows machine. And I had to do a lot of work, right? It was very frustrating. So I thought it will be very difficult, right? Everyone will face issues, right? Ultimately everyone will go mad that I'm not able to install it, right? So I went with Docker way, right? In Docker, if you see, almost every one of you installed it within 10 minutes, right? Because it is a containerized, right? Whatever I am using in my system, I am giving all of you to you, right? And you are creating a container with same version and everything, and you are not facing any issue, right? So this solved a big problem for me, right? Otherwise, whoever start learning Spark, right, 50% of the problem is installing Spark in your system, right? Because there's a lot of problem that it should have Python version 3. If Spark is this version, Python should be this version, Java should be this version. So I spent time figuring out that. For you, it is just a 10-minute work, right? So this is how Spark solved problem for us, right? And you can install a lot of things like Airflow or whatever you want. It is very easy, right? So this is how it looks like. We have a Docker, everything, code, services, database, libraries, we will put all together, right? So it will have everything and it will work well anywhere. It will work on cloud, it will work on server, it will work on laptop, everywhere it will work, right? So this is how it solve it. So you have an operating system, you have a Docker, and you have different apps. There are few things that you should know. Image, right? Think of an image as a receipt or blueprint. It contains everything needed to run an application, but it is not running yet. Example, Python image, Ubuntu image, Spark image. Container. A container is the running version of the image. When you start an image, it becomes a container. I'll just show you. Right. So you can imagine as image is a class. If you have learned OOPS, there is a concept of class and object. So image is like a class, right? And container is like an object. So you can understand that way, right? And then we have Docker file and Docker Hub. Now, what is Docker Hub? So all the images, right, are available on Docker Hub. You can just directly install from there. So I will just show you. So let me move this. I will say Docker Hub. So this is your Docker Hub, right? And you can search for any image here. So for example, if I need Spark, I can just, this is the Docker official image. So I can get the image from here and use it, right? Now I will show you how we are doing it. So if you see, I have this file, Docker compose file, right? So now what we are doing, right? If we go back to the Spark architecture, um, let me go to the Spark architecture. This is the architecture, right? So we need to, so what we are doing is we are creating a uh, Spark cluster. In that we have two executors, right? We can create more also, but we have created two because we have limited capacity in our laptops, right? So we have two executor, one cluster manager and one driver, right? These four things I need basically, right? Now if I go back here and I open my compose, right? So I need multiple images, right? So this is my Spark master and I'm using this Spark image, right? So it is directly taken from the Docker Hub, right? And this is the name I'm giving, right? And this is all I'm giving, that what will be the port, web UI port, and all of that information. And the volumes, basically what disk space it will use. Similarly, I have a worker, right? So worker is this one, right? Again, I'm installing the Spark image for worker as well, right? I'm giving that, okay, this worker should have two cores and memory 2 GB, right? Again, what disk volumes and ports, right? Then we have worker 2. So we are creating multiple containers, right? So imagine now in my system, there are small different systems, right? And it becomes a cluster, right? Cluster is basically multiple computers working together. So that's what I'm giving. I'm creating small container and that will become my container. Sorry, cluster, right? So it will, we are just mimicking exactly what we needed, right? We needed a cluster. So instead of multiple computers in one computers, we created a small container and they are working as a cluster together, right? And then we have a S3 server. We can see all the jobs here. And then we have Jupyter, right? Is to run the code. And in the same container, we have the driver as well, right? So in the same container, we have Jupyter as well as the driver, right? I'll show you. So if you go back, uh, Jupyter, right? So this is my Docker file. And in this, I have given what all I need, right? So this is my working as a driver as well, right? You don't have to go in too deep. What all it is, just high level understanding you should have that we have created a cluster kind of thing on our local system using Docker, and then it will work as a actual cluster, right? We can distribute work and do all of that, right? Now, one important thing here is if you think you have low configuration in your system, right? So my system has 10 codes, right? So I can allocate two codes to each worker, and master can have one core, right? So if your system has less codes or less memory, so you can modify it, right? Because then your system will hang if you have less memory. So you can say one core, right? You can see if it is working with two core, it is fine. It is 2 GB memory. You can give 1 GB or 2 GB, or in MB also you can give, right? Similarly for worker 2, right? So this is how you have to do. For driver also, I have given 2 GB memory, right? So basically, this is the overall idea, right? I hope you understand it now. Great. Okay, so this is about Docker. Um, yeah, so let's move on to Spark now. Okay, so we little bit discussed yesterday what is Spark. We understood that this is just a processing engine, right? It is just a replacement of MapReduce, nothing more than that, right? And we also understand that Spark abstracts away the notion that you are writing code to run across cluster, right? In MapReduce, we were writing a code for map and reduce. So we had that in mind that we have a cluster and this is how I should work. But in Spark, not like that, right? You just write a code, just normal code. You don't have to think about clusters and all, and the code will automatically run on cluster. Right? Great. So it is in memory, much faster execution, and we understood at high level the architecture as well. We will keep talking about the architecture throughout our session, so don't worry, right? But we have overall idea that I have a driver, right? I will send my code to driver. Driver will plan everything that how data, what work has to be done, and it will distribute the work, right? In between, before distributing work, he will contact the cluster manager. Cluster manager, he will ask, okay, what are the resources available? So cluster manager will tell, okay, you can take these executor or these worker node and do the work. And then Spark will, sorry, driver will go and distribute the work. Once the work is done, then executor will either write the data or they will return the result to driver. Based on what command we are running, we will see. In some cases, executor will return back the result. In some cases, they will just write it to the output. Okay, so this is all we discussed. Great. Uh, Now talking about this cluster, right? So there are different kind of cluster managers in Spark, right? Just I will touch base on that. So if you see, we have standalone cluster, right? This is what we are using. So this comes with the Spark installation, right? So we are using a standalone cluster. Spark's built-in resource manager with master and worker nodes, best for learning demos and small clusters. Then we have Apache Hadoop Yarn. This is one of the most famous cluster manager, and later we will see the architecture of this, right? For now, if I tell you, it will be very confusing, so don't worry, we'll discuss later. Okay, then we have Kubernetes, Apache Mesos, and they have different pros and cons. You don't have to go deep into this, right? This is at architecture level. Basically, when you are setting up cluster, but don't worry about it. We will discuss about Aeon later, right? Okay, so this is the Spark ecosystem components basically. So we have a core API, right? So we have core APIs in R, SQL, Python, Scala, Java. And then on top of that, we have higher level API. Again, we have SQL, PySpark, we have Spark streaming, right? Machine learning, GraphX, so everything. It is a unified platform, and they have given API to work with the Spark, right? So you can run your code with the core APIs or with the higher level APIs, right? We will understand what is core API, what is higher level API, but basically this is kind of encapsulation of core API only, right? So this higher level API use core APIs only internally, but it gives us more better performance as well as easy to work with, right? And that we will see later, right? So components, Spark Core, basic functionality, RDD, scheduling, memory management. So when I talk about Spark Core, we work with RDD, right? Today we will discuss RDD, what is RDD and how I can do transformations using RDD, right? Then we have Spark SQL, work with structured data using SQL syntax. Spark streaming, real-time data processing. MLib, so we can write machine learning algorithm on Spark. It has all the libraries to for training and all model training. Then this is for graph analytics, social networks. And then we have Spark R and PySpark as well. So R and Python APIs for Spark, right? So all of this is there. In this bootcamp, we are going to learn PySpark as well as Spark SQL. And we will just spend some time on Spark Core as well. So we have some understanding, but no one uses core APIs nowadays, right? And even Spark says that you should not use core APIs. The higher level APIs will give you better performance. And we will discuss why they will give better performance. But at least we should have basic understanding. So we will learn some transformations today with the Spark Core API RDD. Okay, great. So let's talk about Spark Core API now, which is RDD. RDD stands for Resilient Distributed Dataset, right? This is the fundamental low-level API and immutable distributed collection of objects. It's a bit harder to work with RDDs. And then we have higher-level APIs, Spark SQL data frames. We will focus on that. Great, right? Awesome. This all we discussed. Let's move to RDD. Okay. So now we will talk about RDD. What is RDD, right? So RDD stands for Resilient Distributed Dataset. It is the fundamental data abstraction in Spark, an immutable distributed collection of objects spread across multiple nodes in a cluster. In simple words, RDD is a fault-tolerant distributed collection of data that Spark can process in parallel. Okay. That is fine. So let's go word by word. So we are saying resilient distributed data set. So data set is fine. You understand it is a data set. Now what is distributed? Distributed means, let's say you are creating a RDD. So let's say you have a data, orders data, right? So this is your .txt file, let's say. Now you say load this data and create a RDD. Right? As I said, that RDD is the fundamental unit where Spark stores the data, right? So you create a RDD here. Now, what RDD will do the moment you load it, right? This data will be somewhere, maybe in your local system or cloud or SDFS, wherever, doesn't matter, right? You load this data and this data then come into RDD in memory and this will be distributed, which means, let's say your RDD was, let's say 200 MB, right? Now, what Spark will do when it is reading into memory, it will create multiple partitions. Let's say it is creating 10 partitions. I'll tell you how many partitions will be created later when we talk about higher level API. But for example, right? So you have, let's say, 10 partitions it has created of 20 MB each. So now you have 10 partitions, one RDD. It is happening everything in memory, nothing on the disk, right? So this 200 MB data, it has created 10 partitions, and these 10 partitions will be distributed across the executor. So let's say executor or worker node, right? So let's say you have a worker node here. Sorry. This is your worker node. right? And this is again a worker node. So let's say you have three worker node 1, worker node 2, and worker node. So in our cluster, let's say we have three worker nodes or executor. Right? Now what will happen? The moment you create a RDD, it will be distributed. So it has 10 partitions, right? So maybe this worker will have 4 partitions, right? This worker will have, let's say, again 3, and this will have 3. Well, I mean, it will distribute. It can be 5, 2, 2, 1, or whatever, right? But it will be distributed basically to different nodes. This RDD will be distributed. Right? So that when you do some work, when you want to do some transformations, the transformations can be done in parallel, right? So when you do a transformations, this worker node 1 or executor, whatever you call it, right? For now, you understand that worker node and executor is same, right? So this executor will process these 4 partition. This executor will then will process 3 partition, and this will run 3 partition. So we are processing these partitions in parallel, right? If it was not distributed, we had to one machine had to process all the 10 partitions, right? So that then what's the use of distributed machine, right? We are saying that we should be able to do parallel work. If there are 3 machines, I should be able to 3 times faster, right? So when I distribute this across 3 machines, this will work in parallel. This will execute 4 at the same time, 4, 3, 3, right? And your work will be done parallelly. Right? So this is why it is called as distributed. Right? Resilient we will understand in some time. But distributed you understand, and this is a data set. Right? Great. Why RDD was introduced? Before Spark, Hadoop MapReduce disk-based processing, very slow for iterative jobs. RDD solved this by allowing in-memory processing, support reuse of intermediate data, provide fault tolerance without replication. So we will discuss all of this. So this is how it looks like, right? So this is your driver node, right? And these are your worker node. And you have, let's say, 4 worker node. So your RDD will be distributed across 4 machines, right? If it is, let's say, 200 MB of data, or it is based on partitions, right? So if there are 10 partitions, let's say it will have 3 partitions, and when you run some transformations, they all will work parallelly, right? And they will just do the work, right? And this is another representation. Let's say you have RDD, which has this data, right? And then it will be going to 4 different machines, right? It will be distributed. Right? One worker node can have obviously more than one partition. It is not that it will have only one partition, right? Let's say you have 200 partitions and you have 4 machines. So 50, 50, 50, 50 will go to all 4 machines, right? Great. So now what we will do, we will create a RDD and then see, then it will make more sense. But I hope you have some idea now that what is RDD. Okay, so if you look at this, right, this is my master node 8080. Basically, here my cluster manager is there, and it has all the information that this is my worker at this address, and these are 2 workers. This is how you look at it. And there is no running application currently, and these are the old application I would have run earlier. Right. So this is showing you Spark master, and then you can look at the executors as well. So this is your 8080 is master, and if I go localhost 8081, right? This is your executor one, Spark worker, right? This is there. Again, it is saying 2 cores, right? Used 0. We are not using it currently. The moment I create the Spark session, it will say it will occupy all the resources basically, right? So it will say used. Currently, I have not created a Spark session, so they are all, nothing is there. Similarly, you have 8082, right? So now kind of you can see that you have different machines in your system, right? Sorry, 82. Okay. Right. So this is again, executor is not running. Currently, we have one executor in both the machines. We will see later that why we need multiple executor and what is exactly how it will help us, right? But for now, you understand we have one executor in both the machines. Great. This is all we understand, right? Now there is a Sport Jupyter lab, right? This is our driver node 8888, right? And then we have the Spark UI, basically driver UI. which will be on 4040, right? So currently we have not started anything. So it is not showing anything, right? The moment we start some application, we create a session, it will start showing, right? So whatever driver is doing, whatever work driver is planning, we will be able to see here. Okay, great, great. Now let's start with some demo where we will create a RDD and we'll learn how to work with them. So I'll create a session, right? So this is my Spark session, right? Spark session dot builder, and here I have to see master, right? If I don't give this master, then it will work in a local mode, right? It will not work as a cluster. It will just use your local system and it will use all the 10 codes or whatever codes are there, and everything will run in one single machine, right? It will not work as a cluster. So you can run without giving this, but then it will run in a local mode. It will not run as a cluster. Right? Then app name, you can give any app name. So RDD underscore demo, let's say, right? And then dot get dot create, right? Now there are different syntax of giving this chaining we are doing. So we are saying Spark session dot builder dot master dot app name. So what you can also do, you can put everything in, either you put in brackets, right? And you can give like this. Or if you are not putting in brackets, you can even give in single line everything. That also will work. So let's say you give this, then this, then this, and then this. So this will also work. So if I run this, this is working. This is some warning. You can ignore it, right? Or let's say this doesn't look good, right? So one option was you give in brackets and then multi-line, or you can also do this. So you can just say continuation. For that, you have to use this uh, backward slash, I think. This one, right? So this is kind of continuation. Don't give any space after that, right? And similarly, I'll say this. This is kind of continuation, right? And so you will see this format also a lot of people use, right? And again, continuation. That's it, right? Let me run this. This is working fine, right? So now this is your Jupyter notebook where you have multiple cells, right? Let me give it some name. Mm, rename Spark day to code, right? And then you can press B to insert a new cell, or you can even click here to create a new cell down. So it will create a new cell, right? Or here also you will get click to add a cell, right? So you can just check if Spark is running or not. So if I run this, it is giving me this, and this is my Spark version, and this is my master, and this is my app name, right? Now if I go to the driver UI, right? This is my driver UI basically, and it will show me, right? Now it is showing me jobs. Currently, I am not running any jobs, nothing, but it will start showing it here once I run something, right? I have just created the Spark session, and if you just go back to, let's say, worker node, or let me go to the master node. Mm, yeah, so let me refresh it. So now you see it is saying two used. So the moment you create a Spark session, it will occupy all the resources, right? In the Spark session, we can tell, no, I don't need all the resources. By default, it is occupying all the resources of your cluster. So it occupies both the cores of both the workers, right? But we will see later that, okay, I want only one core, right? Or I want only less memory. By default, it takes 1 GB memory it gives, right? You see 1024 MB used, right? And overall it's 2 GB, but it is just by default. We have a setting, we can change it. By default, it is giving 1 GB memory to both the workers, right? So this is how you have to understand this cluster thing, right? And this is my application, RDD demo, 4 cores, memory per executor is this. And yeah, it is running. It is also showing the duration. So you should get some uh, feel that you are running a cluster now, right? That's why I'm again showing you all of this. Great. Now let's go and load some data or create a RDD. So now let me show you my uh, Spark setup, right? So you have this data folder, right? So this data folder, you can put your files and read from here, right? So we have orders underscore 40 MB. So I have created different MB size of files, right? You can just create using that script I shared yesterday, right? I think I told that later. Let me explain it again. So if you go to Spark setup, I have a file generate data, right? And you can just run it. It is nothing to do with Docker or something. Just on plain Python, you can run this script and generate orders data, right? Now, how much data you want? You can change the number of rows. So around for 20 million rows, it gives you 1 GB of CSV data, and you can create different files to play with this Spark. You can create 3 MB file, 2 GB file, 5 GB file, right? So we don't have to worry about the data size. And this is the actually, this is wrong name, so you can change the name. So if you are creating 1 GB file, you can say orders underscore 1 GB or so on and so forth, right? So you can change the name. So in your current directory, it will create a orders data directory and then generate this file, right? So this is how it is. Great. Okay. So now let's start reading the data. So what we will do, let me maybe open this data. No, wait. In one of that, I think I have removed the header. So by default, you will get the header, right? In this, I have removed the header in the orders underscore 3 MB file, right? I have removed the header. So that's fine. For purposefully, I have removed the header. Okay. So what we will do, we will start our code. I will say orders underscore RDD equal to Spark. Spark is my session, right? So if I want to enter into Spark application, I have to use Spark. Now to work with the low level API with RDD, right? You have to use the Spark context. So you will say Spark context dot text file. Right? This is all, if you see, is in a camel case also, right? If you see any function that we are using, it is in camel case, which means the first letter of your function will be small case, and the first word will start from the small letter, and then if there's another word, then it will start from capital letter. So you see C is capital, so this is case sensitive, right? And S is small. Again, in this function text file, T is small and F is capital. Even here you can see, right? Builder, there is only one word, so it is just builder. So app name, so A is small, again N is capital. So all the functions are like this, right? Okay, so I will say text file, and now I have to give the path. So path is within data folder. I have orders underscore 300 MB dot CSV. Right? This is my file. Orders underscore 300 MB dot CSV. Right? So I'll just run this. So this command is executed. Now what it has done, not it has done, we will see, but it looks fine. Now what I will say. Now to see the data, so I'll say orders underscore RDD dot take. So take is a function, right? RDD function. And I can say I need 10 records. So I can pass how many records I want to see from this RDD, right? This RDD would have created with this data. And now I'm saying show me 10 records, right? So I'll just run it again. To run, you can press Command Enter, or if you are using if you're using Windows, Command Enter, and if you're using Mac, Command Return, right? Control Enter, sorry, for Windows. Or you can just use this, right? Run this cell. So both works. So let me run this. Okay. So if you see, this is showing me some data, right? 10 records it is showing, right? So if you see, these records are coming in a list kind of thing, right? If you see, this is a list and this is the first element of list. It is a RDD, but it looks like that, right? It is a list, right? Python list, basically, you can think about it. And each record of my file is the one element, right? It doesn't have any tabular structure or anything. It is just a list, you can imagine, and it has all the data as each element of list. So first element of list has first order details, Second has second order details, and it is a full string. See, it is starting with single quotes and full data as it text, and then it is ending. So this is how you will see data in RDD, right? Okay. Now I'm saying orders IDD dot take 10. Now I have some requirement, right? Let's fulfill that requirement, and during that we will learn how to work with RDD. So my requirement is that I want, right? So I have what all I have. Let me write it down. So I have order ID. So first column is order ID, right? Second column is customer ID, right? Then third column is this is product ID. Then we have unit price, right? Then we have order date. Then we have order status, or let me call it status. Then we have state. Then we have quantity. So these are the columns we have. This is how you have to work with RDDs, by the way. There is no column. You can write a column name or something, right? And that's one of the reason that we don't work with RDDs, right? Because it is not that comfort for data engineers to work with RDDs, right? So what I want top five state with highest sales, right? For delivered order, right? So I need to first see how I need to filter on the delivered orders, right? Once the delivered orders I get it, then I need to get state-wise total sales. Now, how I will get sales for each order? I have to multiply this unit price with quantity. So this multiply this will give me sales for each order, and then I need to aggregate it, right? To get it at the state level. And then I will get the top five. So this is what the requirement. Okay, great. Now I have created this orders IRD here. Right? Before I go further, I just want to show you that Spark would have created some partitions. So I will say orders IRD dot get num partitions. Right? What it will give me, it will tell me that how many partitions are created. I have 300 MB data, and when I read it in Spark, how many partitions would have created? So it is telling me 10 partitions, right? So most probably we have two executors, right? Or workers. Executor one, we will see later this in Spark UI, right? But you can imagine that five partitions will be most probably uh, processed by this executor, or they will be available in executor 1, and five partitions will be there in the executor 2 because there are 10. So they can work parallelly. It will execute 5, it will execute 5, right? So you can use this get num partition 1 to get it. Okay, great. Okay, so now let's get back to this requirement, right? That I want top 5 state with highest sales for delivered order. Now, again, before I go there, I want to teach you a couple of things in Python, right? Maybe some of you already know it, but I just want to teach you. I want to teach you map and reduce functions. So this is not map reduce of Hadoop. Don't get confused. These are higher level functions, higher order functions in Python, right? I'll tell you why they are called as higher level order functions, right? Okay. So let's say you have to define a function in Python. So how you will define, right? So you will say def. Let's say you want a square of a number. Square. Let's say number is square, right? So you will take one argument. Let's say num, right? And then you will say return num into num. This is how you will write a Python code, right? Simple, right? You are taking an argument and you are returning a square of it, right? So let me call this function. So I will say number underscore square, right? And then I will say num, right? So num, let's say num is 5, right? And I will pass this num. Okay, so let's run this. So it is giving me 25. Right? So this is how you write a function in Python. You define the function, what arguments it will take, and what it will return. Simple. Now we have a shortcut also, right? If you have a single line function, so if you see this is just a single line function, right? You don't have to do much. You can also achieve this using lambda. So you will say lambda x colon x into x. Right? So you are saying this function will take a argument x and it will return x into x. Right? And you can call it as number square. You can give it any name. So you will say number square equal to lambda x colon x into x. Right? Or maybe let me call it underscore lambda. Using lambda, we are doing it. Right? Now what I can do, I can again call this function and I will say this and I will pass num. And let me run it. So again, let me comment this so that you see this. So see again, it is returning me 25. Right? So this is a shortcut way of writing a function lambda. Right? So lambda is taking one argument and it is returning x into x. If you say let's say x plus x, then it will return 10. Right? So in one line you are writing a function instead of writing def and all of that. Right? This is just a shortcut. Nothing. Don't think that it will have better performance or something. Right? It is just a shortcut of writing simple functions. So if you have simple functions, instead of writing like this, you can write like this. Okay, so you understand what is lambda now, right? Now let's understand map function. Right? So let me do that. So now map is a function which takes, let's say, x argument and it will x number of elements as input and it will return x number of elements. Now they are known as higher order functions because they take functions as an argument. So I will say map and let's say I'm using this lambda x into x, right? And I will pass a list, right? So I want to apply this function to a list, not just one number, right? So either I run a loop or what I can do. So I will say num list equal to, right? You would have run a loop if you have to, if you need a square of all the numbers, right? So you will run a loop and you will call this function again and then append into a dictionary, sorry, list. Now here I can just pass this. Right? Let me call it x into x, right? So this is a function. Within this function, you are passing another function. Right? So this is a higher order functions. Right? Now, if you see, if I just, so it will return an object, right? And to see it, I need to convert it into a list. Right? So if you see, I don't have to run a loop as such, right? It took this num list and it kind of internally would have run a loop and it would have taken 2 and returned 2 into 2. So this is my input and this is my return, what I'm returning, right? So it would have taken 2 and return 4. 3 return 9, 7 return 49, 9 return 81. So the number of input element of a list will be the number of element in the output. This is how this map function works, right? Maybe many of you would not have used, but it is a simple one, right? Not nothing complex as such. Okay, so this is your map function, right? I can assign it to a new list, whatever, right? Right. So this is how it is working. Great. Now let's talk about reduce function, right? So we have a reduce function as well. So this is my map function and this is a reduce. Right? Don't get confused again with map reduce of Hadoop. They are just Python functions, nothing to do with the map reduce of Hadoop, right? So now what reduce will do? Reduce will give you one output basically, right? So let me write. So if I write reduce, right? Now reduce will take two arguments. Let's say lambda x comma y, and it is returning x plus y. So what it is doing essentially, right? So what it is doing essentially is, right? it will take this list, right? I'm passing num underscore list, and it will just add up all the elements. I'm just adding. So it will do 2 plus 3 plus 7 plus 9. I'll just tell you how it works. Right? But basically, this is what it will return. So let me run this. Okay, I need to import reduce function. By default, it is not there. So I think from func tool import reduce. Yeah. Yeah. So I need to import this, right, from function tools. Sorry. Right. So what it is doing essentially, it is giving me the sum of it all 2 plus 3 plus 7 plus 9. Right. Now you would think why why it is showing like this, two arguments, right? Why it is showing like two arguments and then do x plus y? It is little confusing. So how it works internally, right? It will take the first element, right? Plus it will take, so basically it will add one by one. So first it will add 4 plus 9, right? Then, so first time the input will be 4 and 9, right? And it will be like 13. Now in the next iteration, it will take 13 and second argument will be 7. So we have, sorry, 2, 3, not 4, 9, 2, 3. 2, 3. So it will be 5. Right? And next time it will take 5, comma, next element, which is 7. So it will return 12. Right? And then in the next, it will take 12 plus 9. Right? So this is how x, y is working here. Right? Lambda x comma y, x plus y numbers. We are learning this to, because in RDD we have to use these map reduce functions, right, to work with RDD, right? So that's why we are learning it. For PySpark, data frame API, Spark SQL, we don't need to know it, right? But I wanted that you should have at least some basic understanding how to work with RDD, so that you know that what are the pain points with RDD, right? Before we move to PySpark APIs. And 99.99% of the time, you will be working with higher level API. Right? This is just to get an understanding that what are the challenges with RDD. Right? Great. So let me read it also. So this is fine lambda, right? And this we understand map, right? So reduce is same, right? Whatever I showed you, and internal working is like this, right? So it will take 1 plus 2. So this is x, this is y, right? For the first iteration, x, y, it will return x plus y. So once you have this, then it will take the sum of it as 3 plus 3. So x will be 3 and y will be 3. Next time this will be 6. So x will be 6, y will be 4, and it will return 10. So this is how it is working. I hope you understand these two functions now, right? We will use it, right? Another function I wanted to show is this split function. I think most of you will already know it, right? Let me show it quickly again. So let's say you have a string, right? This is kind of data we see in RDD, right? And you want to split it into multiple elements of a list. So you can just say orders row dot split, and you are saying split it based on comma. So if I just run this, you see this is a list, right? And when, let me say orders underscore list, right? Now, if I want to access particular element of this list, I can access using index. So I will say orders list. So let's say if I want the order ID, right? So index starts from 0. So I'll say 0 and this is 1, 2, 3. So if I just want order ID, I will say 1. So it is giving me order ID, right? If I want order date, I will say 0, 1, 2. Sorry, whatever, right? Where is my order date? Order date 0, 1, 2, 3. Okay, so I need to say 3. So this will give me order date. Right? This is all I wanted to teach you on Python. You already know Python, but at least basic understanding I wanted to give how all of this works. Great. Now we are ready to work on RDD, right? So let me start. Okay. So my requirement is this, right? So I have this data now, right? First, I want to split it, right? Because if I don't split it into a list, how I will access the first element, second element, third element. So basically what all columns I need? I need state column, right? I need this column, status column, so that I can get the delivered order. Then I need what I need. I need this quantity column. I need this column, unit price, right? These columns I need. So I'll do a split, and for that I will use the map function. So I will say, let me create here 12. Okay. So I'll say, so this is my orders underscore RDD, right? And I'll say dot map, right? Dot map. Now I will say lambda x colon x dot split and split by comma, right? So what is happening here? So if you remember in map function here, right, we were passing the list here. So if you see map function, where is my map? Yeah. So in map function, I was writing the function and I was passing the list here, right? This is how it was working. And it was running a loop on each element of this list. But here we are directly working on RDD. So it will take the RDD data. So I'm saying RDD.map, which means I don't need to pass a list here. It is already RDD data is there, right? So I'm saying orders.map. So it will take each row, each element of this RDD or list, right? And then it will, what it will do, it will, so this X will be full this data, first element. So the X will be the first element, and then it will generate X dot split using this comma. So let's see what it will return. So I will create a new RDD. So let's say orders split equal to this. This is also a RDD. You can give any name, right? Let's see how it comes out. So it is orders underscore split underscore RDD, and how I will see the data, I will say take. Let's say I want to see first 10 elements only, right? So if you see, it has splitted it, right? It is just showing in multiple lines because of more length or something, but all the data is like this. Don't worry about it. It is just a formatting issue, right? So basically, if you see first row, it has converted into a list. Right? So it is kind of list of list we have. So the first row, we have the order ID. This is my customer ID, product ID, unit price, order date. This is my status, state, and quantity. So I got this. Perfect. Now what in next step, what I will do, I will get only the columns which are required, right? And also what I will do, if you see everything is string, because when I do split, everything comes as a string. Now to multiply this and this, I need to convert them into a integer or float, whatever. So I need to multiply this with this. So this is a float kind of data. So I need to convert it into float. So all of that work I will do in the next step. So I will say, don't worry, you don't have to work like this, right? You don't have to work on RDD. I know it might be feeling a little not that easy or intuitive, right? But earlier, when higher level APIs were not there, right? People used to work like this on Spark. They have to work on RDD to do all the transformations, right? You don't have to take that pain, right? But at least you should know basics of it, right? Great. So now what I'll do, I will say orders underscore RDD dot map, right? Lambda X colon. Now what is X in this case? Now X will be each element like this, right? So what I need, I will create a tuple, right? In that tuple, I will take whatever columns are required. So what I need X, this is 0, this is 1, this is not required, right? 0, 1, 2, this is also not required. I need this 3. Right? 3 is the one where we have unit price. So I will say x3, right? Then what else I need? I need this state. So I will take x, so 0, 1, 2, 3, 4, 5, right? Great. What else I need? I need the status and then state also. So I will say x6. right? And then X7 also. So these four columns I need. Right? So let's see if it is working. Maybe I will put it in a new cell so that we can see the output, right? Yeah. Okay. So I will say RDD dot take 10. Okay. So we are getting 2496. Let's see if it is fine or not. Something is wrong, right? What is this 2496? Uh, mm, lambda x x3 is 2. Okay, let me see. So we have orders split ordered is fine, and then we are saying, oh, I need to do it on this. Sorry, my bad. After splitting, right? So I will say orders data, right? To make it simple, data RDD. My bad. Okay. Right. So once I split the data, then I can use this index to get the values, right? I was using the wrong RDD. Okay. And then I will say this. Yeah, now it is fine. Okay. What is this? I think I have taken wrong. So this is 0, 1, 2, 3, 4, 5, 6, 7, right? So x3, x5, x6, x7. What is the error? Tuple index out of range. Mm, so I'm splitting this, which is fine. Orders split RDD. And then I'm saying x colon x3, 4, 5, 6, 7. Let me check here. I'm doing some mistake, I think. Okay. This is fine. So mm, x6 3 5 6 7, right? Looks fine. Let me quickly check. X3, X5, X6, X7. Okay. Maybe let me run it again. I think I have done some mistake. Okay, let me run this and then again run this. Oh, it is fine. I think I ran the wrong code earlier because of that. Perfect. So now we are getting those four columns. You see, this is my unit price, this is my status, this is my state, and this is my uh, quantity, right? This is what I wanted, right? Now also, and the same step, what I will do, I will convert these two to float, right? Instead of a string, because I need to multiply it. I cannot multiply string. So what I'll do, I will say convert it to float, right? First one and also the last one so that I can multiply it later easily. So now you see it is coming as a float, not as a string. Perfect. Now next what I should do, right? Let me create a new cell again, right? And this is my, this one now. Now I will apply a filter. I'm interested only in delivered orders, right? That is what my requirement is. I want top 5 state with highest sales of delivered order. So I will straight away filter the data, right? So I will say orders RDD dot filter, right? And again, I can pass a filter here, lambda x, right? Now x is this, every time this x is changing, right? This is my input, right? And now this time it will be 0, 1. So I will say x0 equal to delivered, right? So what it will do, it will basically filter the data and give me a new RDD, all the columns, right? This is how this filter works. Great. So I'll say orders filtered RDD. By the way, we can chain all of this together. I'm showing you step by step, but you can chain it. Dot map, dot filter, all of that you can run in one line, right? But you will not understand it, right? So that's why I'm going step by step. But if you want a simpler code, not multiple steps, you can just chain everything together. Okay. So now let's see what we will get. Dot take 10. Okay. Delivered. I think delivered is not there. Delivered is there. Orders data RDD dot filter lambda x 0, not 0. My bad. 1. Okay. 0 is this, right? So I was comparing it and it didn't give me any result because delivered is not there in this first column, right? Okay. Now I'm getting the data, and if you see, I'm getting only the delivered one, right? All of that is filtered. So I have now only the delivered data, which is a perfect thing. Great. What I'll do, maybe I would have done some more um, thing, right? Here, that float this and this, right? So instead of that, maybe I can multiply because I need a multiplication ultimately, right? So I would have directly multiplied it here and kept only 3 columns. So let me do that. I will take it out from here, Control X, and I will multiply it here directly. So float into this. So it will give me the multiplication directly. I don't need to take all the columns till the end, right? And let me run this. So now I'm getting the multiplication directly. So for example, 189 into 2, it is 378, right? Now this will change little bit. Now it will be 0, right? Now it will be 0. Let me run this again. And now it is all fine. Great. So we have got the delivered order. We have got this state, and we have got the sales for each order. Now what all I need is I need to group data based on state and do the sum of sales so that all the Kerala will come together, Chhattisgarh, all the sales will come together. Right? Let me do that. So I will add a new cell. Okay. Now I need to pass this to a reduce by key function. I'll just talk about it, right? For that, I just need to have key and value, right? So I will just take this and this. After this filter, I will use another map function and I will say only give me these two values. This will be my key and this will be my value, right? So I will again use orders final RDD, maybe I can say uh, orders final RDD equal to orders filter RDD dot map, right? And I will have lambda x, and I will return only 2 columns. So I will say x1 and x2, right? Let's see what we have. Dot take 10. Okay. So we have this, right? So this is my key value pair kind of thing, right? So now we have a function which is reduce by key. So we learned reduce, right? We learned reduce function in Python. Similar to that, we have reduce by key. The only thing is in reduce by key, this will be a key. So it will aggregate data based on key, right? Reduce would have added all of this together. But reduce by key, what it will do, it will take Kerala. So this is a key. So it expects a key value pair, reduce by key. So for this each key, it will aggregate data, just like reduce function does it, right? So we will say orders final RDD, orders AGG aggregated data equal to orders final RDD dot reduce by, see, by B is capital and key K is capital, right? So you just have to remember this. And I will say lambda x comma y colon x plus y, right? I need to do aggregation. So I'm saying x comma y, x plus y. I hope you understand this, right? How it is working. I just showed the reduce function. Similar way it works It is a reduce by key. So for each key, it will aggregate the data, right? And let's see what we have now. Okay, dot take, let me do 20 maybe. Maybe we don't have more than that number of states, and let's run this. So it is running something, and if you see, we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe we have more. Let me make it 50 or 40. Okay, so we are getting now sales for each state, right? This is how it is, right? For Tamil Nadu, this is the sales. For Madhya Pradesh, this is the sales, right? Now I said top five, right? So what I need to do, I will have to sort the data. So I will say dot sort, right? Now I need to tell on which column it should be sorted, right? So if I just go back, right, I just need to say that which column I need to sort it by. So I will use sort by. Let me copy this. I am also not very much comfortable. Sometimes I forget the syntax because we don't work with this, right? So this is my RDD, right? And let me remove this. So I'm saying that sorted by the lambda x x1. X1 means this. Again, I have to use the lambda function. Right? So 0th element, first element. So I'm saying sort by the first element, and ascending should be false. So if I just don't give it, it will give me the, in ascending order, it will give me. So let me take 40. Right? So it is ascending order. You see 2035, 2037, right? And then 2071. But I want top five. So I will just go back and say ascending is false, which means it will be in descending order, right? So now if you see, this is in descending order. And this is the top. Himachal Pradesh has highest sales. Then Rajasthan and so on and so forth. And Tamil Nadu has the lowest sales. 2071 you see here and 2035 you see here. Right? And if I want top five, I can just take five. It will give me top five those. Right? These are the top five states. Okay. So what all we learned? We learned map. Map means for each one element, it will give one element. So if there are 10 elements in my RDD, it will give me 10 elements in output based on what transformation I have written. Then we learned also the filter, how to filter data, filter function, right? We also learned reduce by key, and we also learned sort, right? And we learned the take function as well, right? So this is how you work with RDD, right? And you would be thinking that it is not intuitive, right? It is not at all intuitive, right? It doesn't have any structure. It doesn't have column names, right? And that was the one of the problems with RDD. Developers were not that comfortable, right? Now, you should at least, after today's session, a little bit exercise you should do so that at least you get a little bit comfortable, right? It is not mandatory, but still I would say if you are learning Spark, that RDD is the basic thing, right? So at least some hands-on you should do it, right? But I would say even if you don't do it, it is okay, right? Because ultimately you will have to use the higher level APIs, which will be more developer friendly, like SQL kind of things will be there where you can put column names and all of that, right? But I want to tell you that what is the journey, right? Earlier we had map reduce where we were writing map and reduce programs in Java. It was so difficult. Then with Spark, things got little easier, right? We have this RDD. At least we don't have to write Java code, right? Then comes the higher level API, and ultimately we are working with the higher level APIs. Even the Spark, the founder or whoever has invented Spark, they also say that higher level API you should use, not RDD, for better performance, right? Now, why do you think that higher level APIs will give me better performance, right? One reason would be, right, that it doesn't have any structure, right? If you see, it is just a object, right? Python or PySpark doesn't know what is the data type of this. Everything is string, right? When we go to data frames or higher level API, we will have a structure, we will have a column name. They are data types, right? So Spark can do better optimization because it has the data types also. It has the metadata. When I say metadata means data of data. So if you have a table, it will have columns, the data types, number of columns, everything, right? So higher level API will work better. So these are some of the transformations. There are a lot of other transformations in RDD. If you want to learn, you can learn. So when I was creating this course, initially I thought I will teach all of this working with RDD, but later I dropped that idea because you will not work and you will feel why we are learning all of this. If you see, I have this, I almost everything I did it here, right? A lot of transformations and all, right? But you don't have to learn it. Okay, great. Now, one more thing you can learn is that I'm going to teach you now is that we have another function, parallelize, right? I'll tell you what it is. So we have created RDD by reading a file. This is what we have done, right? We read a file. If you see here, this is a function, spark.sparkcontext.txt file, and we are reading a file and it has created a RDD, right? RDD is a some object in memory and it is partitioned, right? We saw that it has created 10 partition Spark, right? We'll see why it created 10 or what, how many it should create ideally. We'll see later when we work with higher level APIs. I don't want to explain those concepts with RDD because ultimately we will work with higher level APIs. So I will explain those concepts when we learn higher level APIs, right? Otherwise there will be a lot of confusion, right? But another way of creating an RDD is parallelize, right? So let me show you. So let's say, so this is fine. So you have a file and now you want to distribute data in memory, right? You want to create a RDD. The moment you create it, now this data will run in cluster, right? You created a RDD which will have partition. It will be distributed across the cluster, right? But let's say you are doing some testing, or you have called a API, let's say, and API has given some response, right? Now you want to put that into the cluster, right? Reading a text file is fine, but let's say you have a data in a data structure of Python data structure. So for example, this is a list. Now you want to do some transformation on this list, but on the cluster, right? If I just do anything here without using this Spark session, it will just run in my driver. It will not go to the cluster. It is not using Spark. So what I want, maybe for testing or whatever purpose, right? I want to move it to the cluster, right? So that I can test my code on Spark, right? Maybe you have a big file, let's say 10 GB of file. Now, before you run data with that file, you want to just create some data on the Python in terms of data structure, and then you want to put it on the cluster. So for that, you have spark.sparkcontext.parallelize, right? So parallelized will take your object and it will create a RDD out of it, right? So RDD dot take file. So now it is in your cluster. Let me take 20. Right? So this data goes into your cluster, right? I think I have another example. Maybe I can show with that. No, I don't have. That's fine, right? But this is what the partitioning will do. Now let me show you a couple of more things. Okay. So okay, so you understand that it has created a RDD. Now let's see, right? Okay, one more thing before I go there. So you have this take function. In take function, you can pass how many rows you want. You have another function collect. Collect will give you all the data. Whatever full data it will show you, right? So if you see, collect is giving me all the data. Now the problem with collect is, right? When you say collect, right? So data will be processed in parallel, right? Within the partitions. When you say collect, all the data has to come to the driver and then it will show you here, right? So if the data is very huge, let's say you have 100 GB of data in your RDD, or let's say 10 GB of data, right? We will see it will go into out of memory exception, right? So I will show you later, but you understand if I do rdd.collect, or maybe let me show you here. So we have this, right? Let me say collect. Let's see what will happen, right? I'm just reading the data and I'll say collect. See, it is giving me all the data, right? It didn't go out of memory because it is just 300 MB of data, right? It is not showing. It is saying that it is too long and it is just interrupting, right? So you should ideally not use collect until unless you need to run a loop over it or do something, right? Because collect will return an object and you can run a loop over it and do things, but ideally you should not use collect. Right? You should use take always when you are working with data and want to get feel of the data. Or if you know that it will be small, then it is fine, right? So I think because of memory thing, it my server went down. Let me run it again. So maybe I will do Docker compose down. Whenever it is something is wrong out of memory, you can say Docker compose down, and you can say Docker compose up again. So it has started the services again. And let me do this. So that's the problem with collect. So if you do collect, it will go out of memory and your application will be kind of hang and it will be gone. Okay, now it is fine, I think. Yeah, so it is back. Right. So you understand that collect has a problem, right? And I told you that once executor executes it, and for some of the things, data will come to the driver. That is one of the things, right? If you do take or collect, all the data will come from executors to driver, right? And if it doesn't fit into driver memory, it will give you out of memory exception, right? So you should use collect with caution. Okay, great. So we were seeing number of partitions. So let me do this, right? RDD is created and I'll say number of partitions. So it has created 4 partitions here. Because why it has created 4 partitions? So when you use a parallelize, what it will do, it will create number of partitions as number of cores you have, right? So there is this property spark context dot default parallelism, and it will be equal to the number of cores you have. So you have 2 executors, each have two cores. Remember, right? Each executor we have given two cores. So value of this is 4, right? Value of this is 4. So by default, it will create 4 partition when you use parallelize. And when you use parallelize, it will create 4 partitions, right? And you can even see that which partitions had what data. So you have this function rdd.glom.collect. If you do that, it is saying that first partition has 3 elements, then this has 3. So all of 4 has three elements, right? Let me maybe make it uneven. Let's say 13, 14, right? Let's see. Okay, so if you see this has three element, internally driver would have done this work that which core which partition will get how much data, right? So you don't have to worry about it, right? So this is how you can distribute one object data into Spark cluster, right? If you have some many times we work with this Python API, and API will give you some response, right? It will be JSON response or something, and you want to again put it into the cluster and do some transformation. So this is how you can do it. Great. Uh, Let me see if everything is covered here. Yeah, I think we are good. Okay. Now let's understand key properties of RDD, right? It is distributed, right? Data is split into partitions. Each partition is processed independently and enables parallelism, right? So we understand this thing, right? Parallelism will be number of partitions, right? So if you have 10 partitions, it will be, um, uh, I mean, 10 partitions will be running parallelly, right? Not all 10 will run parallel. We will see later, right? Another thing is it is immutable, right? So immutable means RDDs cannot be changed. Every operation creates a new RDD, which means let's say I created this RDD here, right? Or let me take this example, right? Now this RDD is created, right? You cannot say that update this RDD. In this RDD, update return to let's say delivered. You cannot do it, right? Like strings are immutable in Python. Similarly, RDDs are immutable. You can create a new RDD, which is fine, but you cannot say update this existing RDD. There is no update command. You cannot delete anything from this RDD. They are immutable. Once they are created, right? So this is what is immutability. Right? Okay. Third thing is resilient, right? I'll come to it. Third thing is resilient, right? Resilient means Spark does not replicate RDD data. Instead, it stores how the RDD was created. If a partition is lost, Spark recomputes it automatically. Okay, and this is also known as DAG. So let me explain it. How does it work, right? So let's say I have this RDD I created, right? RDD1, I loaded a file. Then I did some map transformation. Then I did filter transformation, and then when I did collect, right? These four things I'm doing, right? Now what happens when you do this? You do this, you this, right? Spark is not executing anything. It is just creating a directed acyclic graph, or also known as DAG. So it is just creating the plan that, okay, first we have to load the file, then I have to apply this map transformation, then I have to apply this filter transformation, and it will not do anything. It will just wait, right? So when you say collect, right? When you say collect, that time it will use this DAG and apply all of this together, right? I can show you. So uh, let me do this. Uh, Let me create one more up. Okay. And I'll take this and I'll take this, right? And then let me take one more, this. Okay. Now you see I'm reading a data, then applying a map, then again a map. Let me take a filter as well. So let me take this as well, right? So I'm doing the four things here. I'm reading a text file, then there's a map transformation, filter transformation. And let me run this cell. I'll just run this cell. You see, immediately it has done. Nothing has happened, right? Because this is not executed. Spark has not created this RDD. Spark has not created this orders split RDD. Spark has not done. There is no object in the system which contains data. Nothing has happened, right? The moment you say collect, now Spark understand, okay, you want to see this data, right? Unless and until you need this data, either you are writing this data or you want to see this data, Spark will not do anything. And this is known as lazy evaluation, right? It will not evaluate line by line. If you are working in pandas, I'm just giving you one example, right? If you are working in pandas, in every step it creates new data frame pandas, right? But Spark is a lazy, right? We are all told that lazy is a bad thing, but lazy is a good thing, I'll tell you, in terms of Spark, right? So it will just create a plan, right? There will be a DAG, we will see in the Spark UI, and it will have all the information. Okay, whenever someone will say collect or something, right? I will just run everything together, right? So this plan is nothing but DAG. I'll go back here, right? This plan is nothing but DAG, that what has to be done. And this plan will be executed once you call collect, or there are some other operations, right? Right? So now it comes to, right, one more concept of transformations and actions, right? So all of this loading file, map, filter are transformations, right? And transformations are lazy. So when you apply a transformation, Spark will not do anything. It will just create a DAG. The moment you call a action, right, then the the code will be executed basically, right? So you have transformations and actions, right? So all transformations are lazy, but actions are not, right? There are two kind of operation is Apache Spark. One is transformations and another one is action, right? So all of this is transformation, and collect is an action. We will see this same behavior with the when we work with higher level APIs, but it is same concept in RDD as well, right? Okay, now let me tell you why the laziness is good. Let me give you a couple of examples. Why laziness is good. Okay. Let's say you are you are reading this data. RDD1 load orders 1 GB data, and you are saying RDD1 dot take 10. Right? If it was not lazy, If a Spark was not lazy, it will just read all the data, right? It will create a RDD with 1 GB data. And then you are saying, give me just 10 records randomly. So don't you think it was unnecessary? Why to load all the 1 GB data? It will just read one partition, it will take and show you, right? So it will not do that, and it will give you faster results, right? Right? If transformations are not lazy, then RDD1 will load 1 GB of data in memory. As they are lazy, so when you call the action, then it will bring only 10 records from storage to memory. Right? Let's say another example. So you are loading RDD, right? Orders one again 1 GB file. You apply a map. You say price into quantity, right? We have done this. Then you are saying filter the data and give me only technology data. Let's say out of 1 GB data, only 100 MB data was of technology category. If RDD was not lazy, if transformations were not lazy, you will do this for all the 1 GB records. Now Spark is smart, right? It will say, okay, you need technology only. So let me filter technology first. So it will move your transformations. It will say, okay, I will first filter the data and then I will apply this multiplication only for that data. Right? So internally Spark will do that kind of optimization, and it is able to do because transformations are lazy, right? So it is not executing anything. When you say collect is an action, right? We have other actions like count, write, right? So we have all of these are actions, right? When we learn again data frame API, we will see what are different transformations as actions, right? If you do count is also an action. So let me show you. Uh, So we have this, right? And it didn't do anything, you see, right? And if I say dot count, right, it will just run. See, now it is running the job and all of these things. And when this was not there, it was just simply sitting, created a DAG, right? And we understand that why it is a good thing, why transformations are lazy, and how Spark can use it for the benefit of performance. Right? So you understand what are transformations? Transformations are lazy, but actions are eager. They are not lazy. Okay, great. So great. We understand all of this. Load, map, filter, collect. Great. I think this is all we wanted to learn on RDD. We have to move to higher level API now, right? So what I will do, we don't have much time. We have only half an hour, right? So what I'll do, I'll just start little bit and then I'll take down, right? So we will start with data frame APIs, right? I'll just show you how to read data and all of that stuff so that you can play with it during your weekdays, right? We have classes on next Saturday. Okay. So let me take data frame API. Okay, great. So, high level APIs in Spark, a high level API lets you describe what you want to do with data, not how to execute it, right? We just have to tell that I want this and that's it. For RDD, we have to just tell everything that extract this and then do this, that, right? APIs like DataFrame and Spark SQL provide schema and metadata, allowing Spark to automatically optimize execution, right? In case of RDD, we didn't have any schema. We didn't have column name. We didn't have data type. It is nullable, not nullable, nothing. It is just an object, right? So Spark can't do much, right? But with data frame APIs or Spark SQL, it has the metadata as well, right? So it will see, okay, this column is integer, this column is date, this column is falana, this column is this, right? And it will just make code simpler, faster, and more maintainable than low level RDD APIs. I'll give you assignments on RDD APIs. So whatever we have learned, at least you should practice that, right? Great. So we have data frames, as we know, distributed data with schema and metadata, like an RDD, but with structure, right? It looks like RDD, but it has the structure. It has the column names and the data types. Right? It is not persistent, disappears when Spark session ends, right? It is like RDD only. So once I session end, this RDD is gone. It is not getting stored anywhere. So you understand it is all in memory, right? So it is getting in memory, and it will disappear once the session is over, right? Faster because Spark can optimize using schema. So we'll learn what is catalyst optimization, what is tungsten later. Then we have Spark SQL, data stored on disk plus metadata in metastore, right? So we can persist the data basically, right? We can create a table and we can persist the data in the disk. So next time, let's say your session is over. Now you come back later tomorrow, you can start the session and read the data from the tables directly, right? So we will store the data on disk and metadata on metastore, right? This creates a persistent Spark table. Best for analytics, ETL, since SQL is highly optimized. Uses the same engine as data frames, but persists metadata. So data frame API and Spark SQL both uses the same SQL engine. Right? The only thing is you can persist the data with SQL, but with data frames, it is everything on the fly. Once you do all the transformation, you can just write back the data. Right? But data frames as such, the objects will not be there. Your data will be written, and once to end the session, that data frame is gone. Right? And third, we have higher level APIs. We have the data sets. Right? This is language specific, strongly typed API only in Scala and Java. Right? So these data sets are specific to Scala and Java. It doesn't support SQL and Python. Right? Python developers rarely interact with data sets. So we don't use data sets, and we will not learn also, and no one uses it. People use either data frame API or Spark SQL. And so we will learn that. This will understand that RDD was low-level API, raw distributed data without schema or metadata. Spark cannot optimize well because it knows nothing about structure. Mostly avoided in real projects. Important only to understand Spark internals, right? So we understand that RDD is nothing but the distributed memory object, right? Resilient distributed data set. Great. I was also telling resilient, right? There was a word, so we didn't discuss, I think, right? So what do you mean by resilient, right? Let me go back quickly. Spark does not replicate RDD data. Instead, it stores how RDD was created, right? Using DAG. If a partition is lost, Spark recomputes it automatically, right? So it created this plan, right? So let's say it created this plan, and let's say after some transformations, one of the partitions was lost, right? Let's say after filter, there was some issue and this RDD was lost. Let's say RDD3 was lost. So what it will do, it has all the plan. So it will create that RDD again. Or maybe it has 10 partitions. Out of that, 4 partitions, let's say 8 partitions are fine. 2 are lost in memory for whatever reasons, right? So for those 2 partitions, it can recreate it because it has all the plan, right? So this is how it is. It is resilient, right? Great. Okay. So higher level API, this we understood. This is all fine, right? Let me create quickly a simple code to read the data using data frame API, right? So we have the Spark session, right? Right? We have the Spark session, and I will say spark.read because I want to read the data, right? Okay. Spark.read dot. Now I need to tell what is my format of data. By default, it is SparkU, right? It is Spark data if you don't give, right? I am saying my data is CSV data, right? I have the CSV data. All of this data is CSV data. And maybe I will read, maybe I will put, maybe I'll read 1 GB of data this time, right? Okay. So I'm saying that read dot format CSV, right? Now I can give more options. So I can say option, and I will say header. Basically, I'm telling header is there or not in my file. So I'll say true. In my file, header is there. I'll show you, right? I'm saying true, right? And then there are a bunch of more options we will discuss. And again, for continuation, you can do like this, right? But make sure there is no space after this. You can have space before this, right? And then I will say load. And now dot load, I think. Yeah. And here I will pass my data. So I'll say data and orders underscore 1 GB dot CSV. And let me call it df underscore orders. Okay, so it will create a data frame, right? And this is what I'm saying is spark dot read. This means read the data. My format is CSV. Header is there in my data and load this data, right? And I will run this. It is running. It didn't take much time, right? It means again, it is not doing anything, right? It is just uh, it's a transformation. We didn't do any action, right? So it didn't take time. Otherwise, it will take some time to read the 1 GB data, right? Now, to read the data, right? So you can say df orders dot show. Show is like take. You can pass how many rows you want to see. Collect again works here, but it will again bring all the data. We don't want that. Our driver will go out of memory, right? Because it is 1 GB data, right? So I'll say df orders dot show, and you can pass how many you want to see. So show is an action, right? And collect is also action, but this is we are just reading it. So I'll just say df orders dot show, and I'll run it. So it is showing me the data. See, because it shows 20 rows, it brought the data very fast, right? It is very smart, right? It is lazy evaluation. So when you say show, Spark knows only 20 rows I need to get. So that's why it came very fast. If I do collect, it will take time because it has to get all the rows. Now it looks like my table, right? Now I feel very good, very comfortable. Okay, I have the column names and I have the data, right? You can see the schema as well, right? So df orders dot print, again P is capital, schema. If I run this, currently it is saying everything is string, right? Because we have not given any schema. We have not told Spark that what is order ID, what is customer ID, it is int or whatever, right? So by default, it will take everything as string, and null label is everything is true by default. But I want to infer a schema, right? That's what I'm been telling that Spark knows the metadata, data types. So this is not, it should be, right? This is wrong. So now how you will give the schema, right? So you can provide another option and you can say dot infer schema, and you will say true. By default, infer schema is false. So it is not inferring the schema. Now I'm saying dot infer schema, right? So let me run this and show you something different will happen, right? So I'm giving, sorry, I have to give dot option. I can pass all the options. There are different syntax also we will learn later, but this is very common syntax. You give format and you pass different options here, right? Again, you can go to the next line. Generally, you will see this kind of thing. Let me do this. Right. Now I'm saying infer schema equal to true, and I will run this. Now, if you see it is running something, right? We didn't call any action, but still it is doing something. Why? Because it has to run something, right? We will learn about what is job basically, right? But basically, what will happen when you say option infer schema equal to true, it has to go and check the data and infer the schema, right? That what are the data types. So that's why one job would have been triggered, right? I'll talk about jobs and all in the next session. But basically, something it is doing, right? It was not lazy operation. That's what I'm saying. The moment you say infer schema equal to true, it is no more a lazy operation because the moment you do it, it has to know the schema of your file, right? And now if you do df orders dot print schema, it will tell you it is integer, it is integer, it is double, it is date, it is string, it is string, it is integer. So Spark has read the data, right? By default, it will read all the data, right? And infer that what should be the data type, right? Now, let's say you don't want that Spark should read all the data, right? Because let's say if you have 100 GB of data, and for inferring it, if it will read 100 GB of data, it will take a lot of time, right? So you can give a sampling ratio. So if I go there, uh, somewhere it should be there. Sampling ratio. Let me search. Sampling. Sampling. Yeah. So you can pass sampling ratio. This is a different syntax. Don't worry. Right. So let me go there and I will say dot option sampling ratio 0.1. That's a different syntax. I will talk about it in the next session. Okay, so what I'm saying, 0.1 means that you check only the 10% of data. Whatever data I have, just check the 10% of data and infer the schema. Right? Don't check all 100 GB data. Right? If you give one means by default, one means you check all the data. But I'm saying, okay, check only the 10% data or 5% data. Right? And let me run this now. Okay, I forgot this continuation. Right? Now it will be little faster, right? When it was 1, it would have taken some time because it would have read the 1 GB data, right? See, it is taking more time. You can see it actually, right? And when I say 0.1, right? It is fast. See, it is faster, right? And we would have got the same schema, right? Because in 100 MB data also it can infer, right? I can even reduce it. Just check the 1%, 0.01, right? It is even faster, right? So see, with 0.1 also is it's like a 10 MB data, right? If I like make very, very small, very small, right? So maybe it will not even read one row. Let's see. See, everything is coming as a string. So when you do 0.0001% of your data, it will be less than zero, right? So it is not reading anything, but you got the idea, right? You can give your sampling ratio that, okay, read 10% data instead of 1 GB data and get me the schema, right? Great. So this is how you can now work with your data frame. So this is your data frame, right? And we will see how to work with that. Now, before you go, right? Because I want you to play with this data, right? Because you have time. So I'll show you one more thing. It was not in today's agenda, but what you can do now, some cool thing. Let me keep it as it is. I'll share this notebook, right? You can create a temporary view and you can write a SQL on this data, right? And it will run on Spark cluster. So I'll say DF orders, right? In next session, we will spend a lot of time on Spark UI. I have not taken it you to the Spark UI because once we go there, we want to understand everything, right? So we'll discuss about it in the next section, next session. So you can say dot. You can press tab actually, so it will show you all the functions available. So if I say CRE and then press tab, it will show you all the functions starting with CRE. So I will say create or replace temp view, right? And I will give it a name orders. What it will do, it will create a temporary table in memory, right? Which will be the name will be orders, right? So I'll just run this, right? Now you can run any query on it. So you can say spark.sql, right? Select star from orders where let's say order status equal to, right? And let's say placed, right? And it will just run, right? Now, what spark.sql will do, it will run this SQL and return you the data frame only, right? So it will not show you anything if I just do this. It will say it is returning this data frame, right? Unless and until you apply a action, show, collect, it will not do anything. It will again create a plan and everything, right? So I will say show, or I can move into another data frame. So it returns a data frame as I said, whenever you write this SQL. So df underscore, let's say placed equal to, you can directly put dot show here as well, but I'm just telling you separately dot show, right? And you see we have only placed order, right? Now, even if you don't know the data frame API, right, you can just read data and convert it into a create or replace temp view and write your SQL one after another. You can write this complex SQL, do all the transformation in SQL. And performance wise, both are equal, right? All these filters and aggregation we can use using PySpark API, right? Data frame operations, right? But you can also write the SQL. And don't think that performance will be less with SQL. No, right? So performance will be equal with SQL or the API operations, right? But you can write now your code, you can do all the transformation in Spark, right? Just after the second session, because you know the SQL, right? And I'm expecting that you should know the basic SQL. I will not teach you that what is join, what is aggregation. I'm expecting you should know that, right? I'll teach you how to do that and performance things about it. But I will not tell you what is aggregation, what is join. I'm expecting you should know it, right? The prerequisite was basic SQL and Python. So when I say basic, you should know what is filter, what is join, what is aggregation, right? So those things you should know. Other things I will explain how to do it, performance impact of it, how to optimize. Right. So it will return a data frame. You can again do the data frame operations on this, or you can create another temp view on this. Right. And it is temp view, which means the moment you say spark.stop, right? So your application is running currently, right? So if I just show you here, your applications are running, right? We ran multiple jobs. What is job again, you don't know currently, but it has done a lot of work whatever today we did, and it is showing me, right? The moment I say spark.stop, let me do that, everything will go away. And you should do that. It will free up all the memory and all. Right? And if your Spark session is running here, and if I open one more session here and run my code, it will not get any resources, because the moment you created the session here, it occupied all the resources, right? So when you run a job here, it will be waiting for the resources. You will get a warning that no resources, no resources, no resources. So if you have opened a new tab, make sure you do spark.stop in the previous one, right? So that all the resources will be released, right? Now, if I go, this will be gone. See, it is gone, right? There is no application running, right? If I go to history server, this would have come. So this history server has all the history, right? The moment you do spark.stop, that job will start coming here, right? So if I just do this, see, this is what we did today. We created this RDD demo session, and whatever we ran in this, you can come here and see, right? So this is a history. Tomorrow, let's say you ran some job and you want to go back and see the Spark UI, you can come here and see, right? So this is your history server. If you see here, all the jobs are stored. So event logs. See, this is the app. This is for each session that you created between Spark session start and stop, right? That will be one session until you say stop. So all data will be going in the app history server, and for each of that one file will be there. So 1, 2, 3, 4, 5, 6, 7, 8 are there, and here also you will see 8, maybe 7 or 8, whatever. This is local actually. This is not the app. So you have 7 and here also 7, right? So now, if you want, you can just do all the transformations, whatever you want, right? And I'll just leave you by telling that you can now write this data back to disk. So let me do that, right? For write API, right? I have a separate session completely, but just to give you idea, so you can say df placed. So it will uh, filter the data, and then I'm going to write it. Instead of read, I'm saying dot write. Dot mode. So there are two modes mainly, right? One is override mode, one is append mode. So if it is already there, if you want to overwrite it, so it will overwrite. If you want to append the data, it will append it. So I'll say mode overwrite, right? Dot in which format. So if you don't give any format, it will be Parquet format. We'll discuss Parquet format later, but for now I'm saying dot format CSV dot save, and you can give the path. So basically you have to give a folder here that in this folder data should go. right? Because it creates multiple file. Why it creates multiple file, we will discuss. But basically, you are saying dir_place.write.mode override format CSV and save this data in the orders folder, within data orders folder, and let me run this. There is some error. Okay, I have stopped the Spark session, right? Nothing is there. Let me start it again. Okay, and I have to create everything. Give me a minute. Oh, this is done. And create this table and then run this. Yeah. You will understand this stage and all in the next session. Next session is the most exciting session, I will say, of this bootcamp. Trust me. The full core of Spark we are going to learn in next Saturday session. So make sure you don't miss it, right? And I will go here, data. See, it created this orders folder and it has written some files, right? Why it has written so many files, we will discuss, don't worry. But basically, it has created files. And if you open this, this is our CSV data, simple, right? It has created multiple parts of it because it has processed in the multiple parallelly in the partitions. So that's why you are seeing this. See, this is the data basically. We have not told header, right? So we missed it, but you understand it, right? We don't have a header in this. Right? This is a number app, not intuitive. This is not a header as such. This is just the data. It shows first row as gray color by default in the numbers app in Mac. Right? So there are multiple parts, and if you want to read it back, you can again read it by giving the folder directly, right? So if I just show you the last command of today, if you want to read it back, right? So you will say, you will take this, come. Sorry, we didn't take the break today. My bad. What happened? Why it is not coming? Okay, maybe down. Okay, I will remove this. I don't know. Okay, it came now. Okay, so instead of this file, right, I will just say orders. Right now, it will read all the data from the orders folder. All the CSV files which are present in orders folder, it will just read it. Right, and you have a success files. If you are writing the data and it is success, all the partitions are written to the disk, you will get this success file. Right, but when you read it, it will not read this. It is just read the CSV files. Right? So it will just read it. And let me do df_orders.show. See, it is coming as this because we didn't give the headers. We can do it, but basically you can do this here. I can say header equal to false instead, right? We don't have headers. So I'll say headers equal to false, right? So it is giving us C0, C1. We will see how we can give the column names in the next session. But basically, you see, I'm able to read the data, placed, right? So I hope you are getting some feel of working on cluster, working on Spark, right? Uh, Next week will be just amazing week. You will be just blown away with what Spark does in next week. So very exciting time is ahead. Yeah, that's it for today. What I will do is I'll just give you some assignments on RDD as well as now I can give you assignments on data frame also because I have not taught you data frames as such, but I have told you how you can run SQL. So you can just convert it to SQL and you can solve the questions, right? So you will just practice SQL in that manner, right? So just practice SQL and write it back, or if you don't want to write it back, just do show and see the results whatever you want. In show you can pass just numbers. So for example, it is showing 20 rows, you want to see 100 rows, you can pass 100 rows. It will show you 100 rows. Okay, great. That is it for today. We are on time and we didn't take break. I didn't feel like taking break because we were uh, in in middle of something and didn't want to break it. After RTD, there was only half an hour left, so I just completed it. Generally, we take breaks after 1 hour, but today we didn't. Okay, great. You can unmute one by one, everyone. Nachiket, we will take the doubts.
Hey, Ankit, thanks for today's session. I have a question on the cell number one where we created the master Spark
Mhm.
master colon 7077. So doubt is here like what this URL is representing and how what difference does it has with the Spark driver? What
So
does
this
it
is a
represent?
Spark Master. This is where your resource cluster manager is, right? So if you go to 7077 port, this is your master, right? It has all the resource that you have two workers, and this is the application running. So it has all the information. So we are telling that use this Spark Master or resource manager for this Spark session, right? If you don't pass this, right? If you
Mhm.
are passing it, which means this is your master, right? And it will have information that which executors it has to give data to, right? If you
Okay.
don't pass it, it will just run locally. It will not use your cluster. It will just run everything on driver. Your data will not go to the cluster. It will just use the local driver to run your code.
Okay. Also,
And your Spark session or Spark application will be running in local mode, not in cluster mode. You can
in
think like that.
Ankit, you also tell that there's a parallelize
Yeah.
function that we apply. So we also have to check it two places. One is to supply the master and to do the parallelize. Then only it become a cluster.
No. So when I created the Spark session, I'm passing this, right?
Mhm.
Or when I'm
Okay,
using a parallelize, I'm saying spark.parallelize. So it has the information, right?
I see.
So if you see, where is my parallelize? Where is, here. So if you see, I'm saying spark context dot parallelize, right? So to work with lower level API, we have to use Spark context. So before, in the earlier version of Spark, we had different context, SQL context, data frame context, this context, Falana context, Hive context. Now everything is
Mhm.
encapsulated inside Spark session only. Okay, so
Understood.
I'm saying Spark context, which means it has the cluster information now. The moment I'm using this Spark, everywhere if you see, I'm using Spark.read,
Yeah,
right?
yeah,
So the moment I use Spark, it has all the information. This is my master, and
yeah.
master will tell these are the executors.
Okay. Ankit, last question. It can we change the port for the master to 7078
You can change in there in your file.
local? I'll try. Thank you,
Yeah,
Ankit.
you can try it. Yeah.
Yeah, hi Ankit. So I
Yeah.
have few questions. So the first one is regarding RDD
Mhm.
and data frame. Okay.
Mhm.